Hello student, I am Dr.A.K. Sinha. Today I am going to discuss polarity of bonds. This is very important for the people. Many question is asked from this chapter, this topic. And now I am going to start polarity of bonds. The existence of 100% ionic or covalent bond representation is difficult. The existence of a 100% ionic or covalent bond represents an ideal situation. In reality, no bond or a compound is either completely covalent or ionic. Even in case of covalent bond between two hydrogen atoms, there is some ionic character. When covalent bond is formed between two similar atoms, as for example H2, O2, Cl2, N2 or F2, the shared pair of electrons is equally attracted by the two atoms. As a result, electron pair is situated exactly between the two identical nuclei. The bond so formed is called non-polar covalent bond, non-polar. Contrary to this, in case of heteronuclear molecules, like HF, hydrogen fluoride, the shared electron pair between the two atoms gets displaced more towards fluorine. Since the electronegativity of fluorine is far greater than that of hydrogen, the resultant covalent bond is polar covalent bond, polar covalent bond, because fluorine has more attraction for electron. Hence, it has attracted little closer to itself. Electron pair went little closer to fluorine. It created charge. In both. That's why it is called polar. Polar means charged. Polar covalent bond. Not fully developed charge, but charge developed. As a result of polarization, the molecule possesses the dipole moment. Here it is important. As a result of polarization, means charge development, the molecule possesses the dipole moment, which can be defined as the product of the magnitude of charge and the distance between the center of positive and negative charge. This dipole moment is defined as the product, means multiplication of the magnitude of charge, how much charge is there, and the distance between the two charge, and the distance between the center of positive and negative charge. It is usually designated by a Greek letter mu. Mu means dipole moment. Mathematically, it is expressed as dipole moment is equal to charge into distance of separation, that is a small r. Charge is denoted as a q, means q into r. That is the dipole moment. Mu is equal to q into r. Dipole moment is usually expressed in dy unit, d, capital D. Question is asked, what is the unit of dipole moment? Then unit of dipole moment is dy unit, d, capital D. The conversion factor is 1d, means 1 dy unit is equal to 3.33564 into 10 to the power minus 30 Coulomb meter, cm, capital C, small m, Coulomb meter, where C is Coulomb and m is the meter. Further, dipole moment is a vector quantity. Vector quantity means it will tell about the direction. Dipole moment is a vector quantity, and by convention it is depicted by a small arrow charge with a tail on the negative center and head pointing towards the positive. Head arrow, that is a head pointing towards positive and tail pointing towards negative. But in chemistry, actually, this is in physics, that is a notation vector. But here in chemistry, minor change is there, minor change. But in chemistry, presence of a dipole moment is represented by the crossed arrow. Crossed arrow means here arrow sign will be there, but near the tail end point, just like a plus sign will be there, plus. Only in there, one vertical line will be there, that will look like a plus. Then here again same way, this is called crossed arrow, put on Lewis structure of molecules. Then here I am telling you what does it indicates. The cross is on positive end, just like a tail, because it is near, the cross is near the tail only. Hence it will be near the positive end, and the arrow head is on negative, just like vector. What is same way in that just like in the place of tail, now we can tell cross. That only difference. Arrow always will be towards, in both cases, towards electron. For example, the dipole moment of HF, how will you represent? Then arrow will be HF, you will write H, and bond you can give a small line, and F. Then F, you know, that is most electronegative, means 7 electrons are there with fluorine. Then 6 electrons are there, 1 electron taken part in bond formation, 1 electron from hydrogen, 1 electron from the fluorine, HF bond formed. Then between H and F, one line you can put, that is called a bond, that represents the bond. And 6 electrons will be there, means 3 pair of electron will be there with fluorine. Then arrow sign will be, one arrow sign you put, that arrow sign will be near towards the fluorine, and tail, which is in a form of cross, just like a small plus, that will be near the hydrogen, which is positive. This is a representation of dipole moment. This arrow symbolizes the direction of the shift of electron density in the molecule. Where electron is shifting in that direction, arrow sign will be there. Direction of crossed arrow, is opposite to the conventional direction of dipole moment. Means just like a tail, it will be near the positive. This also will be near the positive. In case of polyatomic molecules, more atoms, at least more than one. In case of polyatomic molecules, the dipole moment not only depend upon the individual dipole moments of bonds, known as bond dipoles, but also on the spatial arrangement of various bonds in the molecule. Correct? Not only with one atom. In case of polyatomic molecules, the dipole moment not only depend upon the individual dipole moments of bonds, known as bond dipoles but also on the spatial arrangement of various bonds. In polyatomic, many bonds is possible. Hence, it depends also upon a spatial arrangement of various bonds in the molecules. In such case, the dipole moment of a molecule is the vector sum of dipole moments of various bonds. You have to add all you can say this dipole moment. You have to add all dipole moments of the bond. For example, H2O. Here 2 hydrogen, 1 oxygen, 3 atoms are there, 2 bond is there, H2O. For example, H2O molecules which has a bent structure. The two OH bonds are oriented at an angle 104.5 degree. Already told you that OH bond, O is in the middle, both H in the down corner, just like bent structure. Then bond angle is 104.5 degree centigrade. Bond angle between two bond is 104.5 degree. Net dipole moment is 6.17 into 10 to the power minus 30 Coulomb meter. Okay. And if you want to tell it in the term of dy, then you have to multiply by 3.33564 into 10 to the power 30 cm. Then it will be, you can tell in the term of dy. Otherwise, you can tell 6.17 into 10 to the power minus 30 cm means cm, that is the Coulomb meter. Okay. This value is the resultant of the dipole moment of two OH bonds. Here you have considered dipole moment of both bond. OH, two OH bond is there, both. Then it becomes 6.17 into 10 to the power minus 30 Coulomb meter. And question is asked, okay, what is the value for net resultant of the dipole moment in water molecules. Then now again its representation is very simple. Same way, OH you have written, O in the middle, HH bent structure, just like a V you can tell. Then how will you tell? Because there is two OH bond. Then now two arrow sign will be there, crossed arrow. Then arrow sign will be towards O. In both bond you write one arrow sign. Then arrow sign will be towards O. In first OH bond, in second OH bond also. And in the end, cross will be near the H in both bond. Then finally you will represent simply after, because two dipole moment is there for two bonds. If you want to represent by one dipole moment, means resultant, then you can write simply OH bond, you write bent structure, and just in front of O you write one cross arrow. Okay. Then arrow will be far. Arrow will be far means positive end will be, end means tail you can tell, near that will be near the oxygen, and arrow will be far. That side nothing is there. That is the resultant. Only it is telling about the direction. That is called resultant dipole moment. That is, it is telling only about the direction. That's why it is just like arrow sign you have written just before the after the oxygen, and tail is near the oxygen, arrow is ahead, It is ahead, nothing is there. Just like it is telling about the direction, like north direction, east direction, west direction, some direction it will tell. That is called resultant dipole moment. Okay, only one aerosign is there, not near the OH or both OH. Okay, that is the individual. But here resultant means only one arrow sign, you have to cross arrow, you have to write. Now, the dipole moment in case of BeF2 beryllium dipolride is 0. Keep in mind, very important question, that dipole moment in case of beryllium fluoride BeF2 is 0. This is a fit question for medical or IIT mains, that what is the value for BeF2? Then it is 0. Why? Then this Y answer is for now for IIT. Why it is like this 0? Then this is because the two equal bond dipoles point in opposite direction. This is the reason. Why it is 0? Because the two equal bond dipoles, both are equal dipoles, but they are in opposite direction. That's why they are cancelling, because the two equal bond dipoles points in opposite direction and cancel the effect of each other. This is for IIT Advanced. That's why you can write like this, straight, linear means straight. BeF2 means B in the middle, 1F left side, 1F right side, and direction you have to show. Then one you can say crossed arrow you have to show, then arrow will be towards fluorine and cross will be near about fluorine. Like that way. Second, in right side, that arrow sign will be towards fluorine and cross sign will be near the beryllium, Be. This is the way how to represent the dipole moment. Now, next you can say, next important these things I am telling you. Example, BeF3 boron trifluoride. In boron trifluoride, here you can see, in case of boron trifluoride BeF3, the dipole moment is 0. In this case also dipole moment is 0, although the BF bonds are oriented at an angle of 120 degree. BF 3 this is there, fluorines are there. Then BF 3 bond is there. Then between the two BF bond, angle is 120 degree. Each BF bond 120 degree. Correct? Just to keep in mind, angle is 120 degree, but dipole moment is 0. Angle is 120 degree. In the first case in BeF2, I told you 180 degree, a straight line. But here, there a straight line was there, then it became 0, opposite. This was opposite direct. Dipole where equal dipole point in opposite direction. But here 120 degree is there, not 180 degree, 120 degree, then also it is 0. How? Then this is also for IIT question. Why it happens? Then here BF bonds are oriented at an angle of 120 degree to one another. The three bond moments gives net sum of 0. After adding all the three, it is neutralizing and giving a net sum of 0. Why? Why? Then as the resultant of any two is equal and opposite to the third. Okay, means resultant of two bond is equal and opposite to the third bond. That's why it is becoming 0. Again listen, resultant of any two bond is equal and opposite to the third. That's why it is 0. Then simply you can write this structure also. BF3 is there. Then for each bond, 3 bond is there, BF, VF, VF. Then you can write arrow sign, cross arrow sign, same way. That arrow towards fluorine and cross to near the boron. In all 3 bonds you can write same way. Then now finally 1/4 arrow sign you have to write, that is resultant. Then again you write in the same way what I discussed earlier, that one cross arrow, that is a resultant you can write. Then arrow sign will be ahead, that side nothing is there, but this cross, that is the tail what you are telling, that will be near the boron, that is telling about the resultant. Then for the 2 bond, what is the resultant? That is equal to opposite means third one. That's why it is becoming neutral, and that's why 0. You can tell 0. Now you can understand next example, that is ammonia gas, NH3. Interesting case of NH3. Here what NH3 and NF3 both you can understand. NH3 and NF3, nitrogen trifluoride molecule. Both the molecules have a pyramidal shape with a lone pair of electrons. Pyramid you have seen, like that type of shape is there. And both the molecules have a pyramid shape. Question is asked, what is the shape of ammonia and nitrogen trifluoride? Question is asked for in main. Then it has this thing, pyramid shape. Both the molecules have pyramidal shape with a lone pair of electrons on nitrogen atom. Okay, a lone pair of electron on nitrogen atom. Although fluorine is more electronegative than nitrogen, the resultant dipole moment of NH3 is 4.90 into 10 to the power minus 30 coulomb meter cm. It is greater than that of NF3. Actually, theoretically it should be, NF3 should have more, but actually it is less. Its value is 0.8 into 10 to the power minus 30 coulomb meter. Again question is asked on this, why less? Then answer I am telling you. Then this type of again question, why means IIT, IIT or higher examination. This is because in case of ammonia, the orbital dipole moment due to lone pair is in the same direction as the resultant dipole moment of NH. Means resultant direction is also in the same direction like NH. 3 NH is there. Then their direction and resultant direction. Finally, resultant of 3, fourth one, what I am telling, that is in the same direction. Whereas in NF3, the orbital orbital dipole. The orbital dipole is in the direction opposite to the resultant dipole moment of the 3NF bond. See, their resultant all were in the same direction, but here in NF3, resultant is opposite to the 3NF. 3NF bond, their direction is different from resultant. They are opposite. That's why value decreased. Opposite means they will cancel. Not fully, but it will cancel. That's why value became less. In NS3, I told you it was 4.90. Now here it became 0.8. So less. And 10 to the power minus 30 is common in both Coulomb meter. This question is very, very important. Now, the orbital dipole, because of lone pair, the orbital dipole because of lone pair decreases the effect of the resultant NF bond moments, already told you, which results in the low dipole moment of NF3. And here if you want to show in a diagram way, then just I told you everything you imagine in mind only, you make habit, because in examination no pen, paper, no calculator, all things you have to do in mind. Then here just try to imagine what I am telling you, listen carefully, then diagram quickly will understand. Here, as for example, NS3, N will be in the middle and 3 bonds are there. Then all 3 bonds will be down only. Then here, again same way you have to write that arrow sign, cross arrow. Then arrow will be towards nitrogen and cross will be near the H, because N is electronegative. Then all 3 bonds, same thing will happen. All arrow sign will be towards the N and all cross will be near the hydrogen. And resultant what I told you in the same way, where arrow sign is there, all 3 arrow signs are there towards nitrogen. Then now resultant also is far from going ahead, nothing is there, and cross is near the nitrogen, but arrow is far, no atoms, no molecules are there. That is a resultant, only it is telling the direction. Okay, then this is the representation. Same way you will represent for NF3, but here difference is, here is a little different, because nitrogen is in the center, but fluorine is more negative. Fluorine is more electronegative. Hence, obviously, in the case of just in NS3, in the place of H, now you write F, fluorine. This is the important things to understand. In N and H, N was more electronegative and H was least, very less. It is electropositive actually. But here in NF3, N is in the center and F is more electronegative, most electronegative. And in the place of H, now here it is, in case of NF3, F is there. Then obviously that electron direction will be, electron shift will be towards the fluorine, means arrow sign will be towards fluorine. In all three bond, arrow sign will be towards fluorine, and resultant will be as it is what was in the case of NS3. Here also in the same direction, but now it has changed. There three arrow sign, that their direction changed. Now all are shift. we can say electrons are shifting towards fluorine, means arrow sign will be in that direction only. That is the rule. Okay, it is representing the shift direction of shifting of electron. Okay, this I have told you. Now these things again further is just to understand. I will give you some examples. I will tell you now. Just as all the covalent bonds, listen here carefully, just as all the covalent bonds have some partial ionic character, name is covalent, but covalent bond also have some partial ionic character. As for example, HCl. In HCl, ionic character is around 80%, around maybe 29 point something. Rest is covalent character. You can't think that covalent means 100% covalent. Ionic means 100% ionic. Not like this. Because it is depending on the situation of electrons pair. Electrons. When electron is, we can say, shifted more toward the electronegative atom, then obviously charge will develop in both. From where it went toward the electronegative, there will be negative, other will be positive, but they have not gone very close. Then according to the situation where electron pair is there, accordingly it will be there. If in the middle, 100% middle, then it will be covalent bond. But pair is little shifted toward the negative, then they will have some ionic character. Okay, this is the situation. Then position of electron decides the polarity, whether it is ionic or covalent. Then this is important things I told you. Just as all the covalent bonds have some partial ionic character, the ionic bonds also have partial covalent character. The partial covalent character of ionic bonds was discussed by Fusion. Fusion was the scientist. Fusion rule, what you are telling, that is actually different. But here, the partial covalent character, the partial covalent character of ionic bonds, for ionic bonds only, it was discussed by Fusions. Okay. Then I will come to the fusions. What are these things? How partial covalent character develops a partial covalent character of ionic bonds. I will discuss, which is discussed by fusion. I will discuss, but now just to understand some, you can say, examples that is actually asked in examination. Then here example I will tell you, and types of molecules I will tell you. First I will tell types of molecules, like AB type, linear AB, and another type is AB2, means A will be in the middle, left side B, right side B, AB2. Third type I will tell you AB3, means it will be just like a trigonal, AB3, like that way. Fourth I will tell about type AB4, that is AB4, means A will be in the middle and surrounding 4B will be there, AB4. Okay, then because in all examination this question is asked, and example I will also tell you. Okay, and what is the dipole moment value, I will tell you. And finally I will tell you what is geometry. All these points are asking. You can't ignore any points. Okay, they will change the question, but these things will be asked. And now I am giving example of AB molecules, capital A, B, capital A, capital B, AB molecules. Then example of AB molecules is first example of AB, that is a HF, hydrogen fluoride. Its dipole moment is 1.78, very high, 1.78, and its geometry is linear, straight. Other example, HCl. HCl 1.07, less than hydrogen fluoride. Reason you are understanding, because fluorine is most electronegative element. Then HCl dipole moment value is 1.07, and it is also linear. Third example is HBr. This is also linear, and its dipole moment value is 0.79, less than HCl. And next is HI, hydrogen iodide. It is also linear, and its value, dipole moment value, that is in mu d, all are representing under the mu. Okay, then its value is very less, 0.38. It is also linear. Molecules AB means linear only. And another example, that is the H2, hydrogen gas. It is 0. Dipole moment value is 0. It is also linear. Now, another example, I am telling about the AB2 type. AB2 type. Then this structure generally AB2, 3 are there. Then it will be just like a triangle bent structure, V-shaped, generally bent, B-E-N-T, bent structure. Then example, actually here it may be straight also. It may be AB2 is there. It may be a straight also, a straight line also, and V-shaped or bent also you can tell, bent, B-E-N-T. Then AB2, H2O. H2O, it's 1.85 is the dipole moment value, and it is a bent structure. Geometry is a bent. Keep in mind very important things I am telling you. H2S, hydrogen sulfide gas, its dipole moment value is 0.95, less than H2O. Okay, and it is also a vent. And carbon dioxide, it is linear, and its dipole moment value is 0. Now I am talking about the third type, AB3, means total 4 is there, A and B3, total 4. Then now its example is NH3, ammonia gas, NH3. Then its dipole moment value is 1.47. Okay, and its geometry is trigonal pyramidal, because 4 are there, then one will be in the top and other 3 will be down. That's why it looks like a pyramidal shape. Trigonal is there already, down it is just like a trigonal shape, but top one item will be there, fourth one, then it will show like a pyramidal. Hence name has been given trigonal pyramidal. Okay. NF3, actually I will send some diagram, you can see, no problem. Some diagram I will say in this video. NF3 is the second example. Here dipole moment is very less, 0.23, and geometry is again same, trigonal pyramidal. And third example is BF3, boron trifluoride. Its value is 0, already discussed. Its value, dipole moment value is 0, and its geometry is a little different, that is the trigonal planar. Question is asked. Now and a last type I am telling you, AB4 type. Then AB4 type means total 5 are there. Then A will be in the center and other four will be surrounding. Then this will make, that is called when one atom is in the center and four are surrounding, just like a square. A square or these things you can say what you can do, 4 points are there, 4 points are there down. Okay, rectangle can tell, rectangle or a square like that. Then total 5 are there, one is the center, other 4 are down. Then that type of structure or geometry is called tetrahedral. Tetrahedral. Then now this example I am telling you, methane, CH4, total 5 is there. C will be in the middle, H will be down surrounding. In 3-dimensional space you will see, then C will be in the middle and 4 hydrogen is there, that will be down. Then that is called geometry is tetrahedral and its dipole moment value is 0. Okay, chloroform, CHCl3, chloroform, then its dipole moment is 1.04. It's also tetrahedral. Generally AB4 means tetrahedral only. Again carbon tetrachloride, CCl4, it's again 0, dipole moment is 0. Generally same atom if it is there, then it will be 0. Okay, then CCl4, same atom is there, it becomes 0. CH4, same atom is there, then it becomes 0. And in all 3 cases, 3 example I given you, in all three are tetrahedral. Now you can understand last things I am discussing, that is the partial covalent character of ionic bond, which was discussed by fusion. I am telling about the condition when they will show ionic bonds are there. In ionic bond, partial covalent character will be there in ionic bond. Then in what condition it will show? Then 3 conditions are there. That 3 conditions I am telling you. First condition is that the smaller the size of the cation, the smaller the size of cation and the larger the size of anion. Okay, this is the condition. If it is like this, then they will have partial covalent character. The greater the covalent character means smaller the size of the cation and the larger the size of an ion, the greater the covalent character of an ionic bond. In that ionic compound, covalent character will be more because one is small, other is big. Obviously, you can say that compound, that molecule will be ionic, but covalent character also it will have. Condition they will ask in examination. Second, the greater the charge on the cation, means sometimes maybe 1, sometimes maybe the 2 positive, 3 positive. Then the greater the charge on the cation, the greater the covalent character of the ionic bond. Correct? Now, third, for cation of the same size, for cations of the same size and charge, if size is also same, charge is also same, in that situation, the one with electronic configuration n-1, d0, ns0, both are 0, 0, no electron in d orbital, no electron in s orbital, means inner d orbital, n-1, d0, ns0. This is the typical transition metals. That is in case of transition metals only. It is more polarizing than the one with a novel gas configuration like ns2, np6. If this electronic configuration is there, any element, if they have ns2, np6 character, then in comparison to that, if other element which has N-1 D0 NS0 character, means transition metals, then in that situation they will have more polarizing. Transition metals have more polarizing than one with a noble gas configuration. Means alkali, typical example is alkali and alkaline earth metals. In comparison to alkali and alkaline earth metal, transition metals will show more, you can say, covalent character in ionic bond. This I have discussed. The cation polarizes the anion. Again, in general way, you understand. The cation polarizes the anion. Polarization means charge development. Pulling the electronic charge towards itself. How they will create? Then by pulling the electronic charge towards itself and thereby increasing the electronic charge between the two. This is precisely what happens in a covalent bond. Covalent bond, that is the build-up of electron charge density between the nuclei. The polarizing power of the cation, the polarizability of the anion, and the extent of distortion means polarization of anion are the factors which determine the percent covalent of the ionic bond. This again you listen. The polarizing power of the cation, the polarizing power of cation, the polarizability of the anion, and the extent of distortion means polarization of anion. These three things I told you. The polarizing power of the cation. What are the polarizing power of the cation? Or polarizing power also you can understand. The polarizability of the anion and the extent of distortion are the factors. These are the factors, three factors I told you. Polarizing power of cation, first factor. The polarizability of the anion, second factor. And the extent of distortion, this is the third factor. Extent of distortion, that is polarization. The extent of distortion of anion. These three things are the factors which determine the percent covalent character of the ionic bond. Question is asked, how will you determine the ionic character, percentage of percent covalent character of the ionic bond? How will you calculate? What are the factors? These three factors I told you. Always this question is asked. Polarizing power of cation, first. Second, polarizability of the anion. And third, extent of distortion, that is also called polarization. These are the three factors which determines the percent covalent character in ionic bond. Then today I am stopping only here. Next class again we will meet. Thank you.